Hello, everyone. So myself and Sheen have come together. We want to talk about operating event-driven architectures. There's a lot of kind of challenges around it, and that's kind of why we've come together to talk about it. Firstly, I'd like to introduce my colleague and mentor, Sheen Brisals, who many of you in the room may know. He works with me. He's an engineering lead at the Lego Group, along with myself as a senior engineer. And also, he became a serverless hero in 2020 because of his huge passion for serverless and event-driven architectures, and he's been creating and innovating ever since. And also, some great news is that this year he came out with serverless development on AWS, his book, and that was along with our colleague Luke Hedger. I call it the serverless Bible because it's basically the go-to for everything serverless, whether you're learning or whether you're experienced. And rumor has it they'll be giving out some free copies later, so I'll tell you a bit more about that at the end. Now, handing over to Sheen.
Thanks, Sarah. So, Sarah Hamilton, and if you notice her, Twitter handle, you will know how much passionate she is with serverless. It's serverless Sarah. And the reason why we decided to give this talk together is because Sarah brings tons of experience in terms of testing serverless, testing event-driven architecture. She has written blogs. She has spoken at Serverless Days Paris in the past about testing event-driven architecture, and also she is the chapter expert in the book talking about the testing aspects of serverless. So, Sarah Hamilton for you. Right, so today's agenda is simple. So we'll just briefly touch on the elements of EDA and some of the challenges we face. And I will hand over to Sarah to take you through to the different aspects of challenges and how we can try and mitigate or overcome some of the challenges. And then we will kind of close the session with some kind of, maybe controversial thoughts on QA's role in serverless and those sort of things. Right. Who was here for the 2022 serverless, EDA day? Right, just a few hands. Okay. So I was here speaking about event-driven architecture and its impact at an enterprise scale. Now, I might have, said one or two jokes, but one of my colleagues, he later said at the office, Sheen, have you ever tried stand-up comedian? I was like, I wasn't sure whether he said, in true sense, or we were just making it up. Now, because I know genetically, this is not a comic face and this is not a comedy piece, right? Every conference I go to, for today, I just travel from home. I usually stand in front of the mirror in the morning before I get to the conference and smile and say, Sheen, smile, because this is a grumpy face. But I do know few people who make us smile. So they always work in pairs and they make us, laugh, smile, all sorts of things. But beyond the comedy, they work as a pair. So when they work as a pair, there is mutual respect. They give enough space for each other. They understand, each other's kind of language. And that's what makes them successful in their, what they do. That's fine. But this is not a comedy show. This is kind of, event-driven. So let's switch over to the current topic of today. So if you check event-driven or modern application, for example, you have serverless compute, you have containers, all sorts of containers, and so many other things, APIs and events and messages and all sorts of things moving around. Because from the business point of view, we need to bring in all these abilities to our application. Now, it doesn't even have cost because I couldn't find a proper word that fits in this sort of, ability way. So this is the challenge we have in modern kind of, systems. To say, for example, if you take extendability, we need to build systems such a way that we can extend it. How do we do that? We think in terms of modularity or modules. So when we have observability, how do you do that? Because I always say that observing something in a pond is way better or easier than observing the whole ocean. So that sort of things that we need to kind of think in terms of building modern event-driven applications. So this is where a duo or a pair come in to kind of help us, make all these things happen. Luckily, in 2022 reInvent keynote, Werner Vogel, CTO of Maison, he said it. So he said the modern, application building basic architecture principles or concepts, asynchrony and event-driven. These two play kind of a, pairing act to make our systems behave and also make us build the systems the right way. So before we, look too much into some of the challenges, let's just simply setting the scene. If you are someone, new to event-driven architecture and asynchronous behaviors. So let's start with a simple synchronous, application or communication. So two services here. One consumer A consumes, service B. It could be like you asking the price of a product or a, stock level or something. So this is a synchronous communication because you as a user behind the, say, a e-commerce website, waiting there to get the price, okay? Because this needs to happen there and then. Good. Let's look at a different scenario. So here, two services, and say service D is like a payment service provider, payment service, okay? So service C, in this case, is, say, shipping or order fulfillment. So what it does is like, so you already kind of, authorize the payments. Before shipping, they need to now transfer the funds from your account to retailer's account. So they submit, the service C submits hundreds of payment IDs to service D. Service D will go out to the banks and the card providers to kind of transfer the money. The way they do is like every so often, it submits a batch of IDs, like hundreds or thousands, depending on how busy the business is. So we have a problem now. Service C cannot wait there waiting for service D to process all the payments and everything. So what happens is service D provides a status endpoint, a typical, command query stuff. So service C keeps polling, okay, to check whether the payment's been kind of transferred, etc., etc. Service C has a problem, not one problem, multiple problems. So for example, how soon should we start polling after submitting a batch? After a minute, 5 minutes, 1 hour? Don't know. Now, how frequently you should keep asking, what is going on? Where are you? Where is the payment, etc.? Every second, every 5 seconds, every hour? Again, hard. And then how long? How many times should it ask? Now you multiply this with number of batches happening same day. So D might have given a batch ID and then all the different payment IDs. So though this is like asynchronous kind of situation, but we have an issue, we have a problem. So bring in event-driven. So now we are pushing the responsibility over to D. So C is kind of, sitting back and relaxing because D now notifies C when something happens. This is the typical simple event-driven architecture in action. So in this situation, C just reacts when it gets notified. It could be individual payments or it could be the batch. It doesn't matter. So, and also you can think of asynchronous when it comes to messaging, right? So a service pushes certain messages to a queue. It's completely kind of decoupled or loosely coupled, and the other service picks it up and processes. So this is like a, the event-driven architecture asynchrony in one page. Okay, so what is event-driven architecture? It's a simple thing like where events kind of drive the action, but things happen asynchronously. Now, if you think of event-driven architecture, a simple thing you might have heard many times today, there are 4 main elements. So there is an event producer, and there is a event carrier, and there are a bunch of consumers. So they all kind of consume events. So this is kind of the four basic things you will hear again and again when we talk about EDA. So in terms of a producer, who is a producer? Someone who publishes an event. So there are certain things that you hear when it comes to a producer. I know in the Dave in the morning keynote, he said, producers should never know about the consumers. That is also the case in most cases, unless it's kind of, your colleague's team as a consumer sitting across. So there are certain things that we need to, put in place for the betterment of the architecture. And similarly, consumers have responsibilities as well. For example, consumers cannot expect, only once delivery. They can expect, the duplicate. So they should be in a position to take care of those things as they consume events. So one of the patterns very common is like consumers, as they receive the events, they often store the event temporarily before processing. There is a name for it called a storage first pattern. Eric Johnson, who is, came up with the name. This is similar to the inbox and outbox pattern. So these are the things that we need to consider when we, build consumers for consumers in the event-driven architecture. So then we have the typical carriers. It's not as different names, event broker or a carrier or an event bus or bridge, etc., etc. But the point is that this is like the transport. You publish the events onto a medium, and it gets to different consumers as required. And of course, you can do filtering and transformations and various other things depending on the capabilities of things. That takes us to the events. So again, you heard many times, event is something that already happens. But what I want to briefly bring to your attention is something Dave touched on earlier keynote, is defining the events. The importance, why you should give the importance to the events when you structure your events. So this is basically a simple event page, event schema. So the detailed part on the left, the blue one, is where we can supply our payload. Any JSON data object we can dump there. But it would make sense for your growth of your architecture to think and bring some structure. So the way I propose this, I've been kind of proposing this structure from since the days of EventBridge, is to separate out into a metadata and data section. What that will allow us to do is like add some of the metadata sort of aspects of the event, separate out from the instance data, that is the data element. So here you can supply the event ID or your own, say, event version, for example. You can also say TTL values. So for example, the downstream consumers, they know that, okay, this event must be persisted, say, 100 days or whatever. So all these kind of information can be, passed across as part of the metadata, whereas the data aspect is basically your order details, your customer data, etc., etc. Okay, so that's all to do with the basics of event-driven architecture. Now, let's move over to the complexities. Again, you already heard the word as part of the keynote, complexities. It is there in modern system. It is there in event-driven architecture. It's kind of, you cannot deny. But why do we do that? Why, if there is complexity, why event-driven architecture is still favorable or favorites of many organizations? There are reasons. But before we get there, let's look at complexities. So, accumulated versus distributed. Has anyone read this book? Good. So I'm not going to talk the content of the book, but I just love the picture or the picture of the book. It basically explains accumulated versus distributed complexity there, if you look carefully. Now, what do I mean by accumulated? Say, typical monolith. I'm not talking about containers here. A monolith application. In the past, we built modules and, all sorts of things. Think that way. Now, what we usually say is, monolith looks so simple, right? Because externally, it's so simple. Everything is within a particular kind of, module, or you wrap things around. But what it is doing is it's hiding the complexity inside. Okay. So that is not visible. And because it's not visible, we just say, oh, it's all fine. Only engineers, fight against these complexities know that is all hidden inside. Whereas if you look at a distributed architecture where it's so obvious that it's so complicated to look from outside, because we have services distributed all around. So here is a bounded context that has a bunch of microservices. There is the payments bounded context that has a bunch of microservices. Then they all communicate via event bus or other brokers and all sorts of things. But the fact is, if you look internally in each of those services or microservices, it's so simple because they all, usually single purpose, do one thing. They have their own kind of individual deployment pipeline. It's kind of so simple. This is one of the reasons why it allows us to satisfy some of those abilities that I mentioned earlier on. So it exists, complexity exists. And it exists because we need to achieve all these abilities. That's fine. But how do we do that? On the other side of the spectrum, we have these things coming along. Incremental and iterative, developer velocity. We need to kind of keep moving fast flow, go, go, go. And then for that, we set up automated pipelines. And then we can deploy anytime, any day, any number. Okay? So keeps going. And then to support that, we have all these kind of, cool things, alerting, alarms, and recoverability, etc., etc. Because business and operational and development needs are all kind of pushing us towards to do this, right? Now, the problem is, this is all fine. So your team busy pushing out a feature, then you see some blip on your dashboard. There is a problem with a service in production. You switch over there to fix that problem, while you still need to push this, fixes and things to other services out to production. So it becomes a kind of a, challenging act. And that's why it's more like a juggling. So you are kind of always, developing something, fixing something, pushing out something, etc., etc. I cannot juggle. How many of you can juggle at least 3 balls? Again, well, just a few. Now, it may look simple and funny, especially when you go to a kid's birthday party or something, but I know it's not. It is kind of a challenging act, right? To have that, you need to have the right balance. So if we take this concept forward, so we have all these, complexities that we list. We also need to satisfy business and other goals to bring in everything else for the business. So that means we have to have a balance, what we call a square of balance. So hand over to Sarah. She will explain everything about how can you balance this.
Thanks. So there's this concept called the square of balance, which our colleague Luke came up with, and it's all described in the book as well. And it really summarizes quite nicely how you might want to operate your system, and the fact that, especially with synchronous systems, that it used to kind of be the test would kind of catch a lot of things, and you would need all of the other that I'm about to explain as well. But this becomes particularly important in event-driven architectures because of the asynchronous nature of it. So, without further ado, the first one is to test your system. So you want to have comprehensive tests, but you don't want to over-test, because you're likely going to want to test on the deployed infrastructure. And by doing this, it's going to be quite time-consuming in your CI/CD, which is why it needs to be balanced with delivery, where also, because of you've probably chosen serverless in order to move quickly as a development team as well. So you want to continue to deliver quickly, but also have well-tested systems. And you also want to balance this with your observability so that if things do go wrong, which they absolutely will, that you get notified ASAP. And then when things do go wrong, you also want to be able to recover. And it's really key that you treat all of these quite equally. And today we're going to focus on test and observe. There's a lot to say, but in the interest of time, let's go deeper into testing and observability. So firstly, starting out with testing, which is kind of my area that I enjoy to work on. So testing strategies tend to be quite different with asynchronous architectures versus traditional synchronous architectures. And the first reason, and probably the most key reason, is due to unpredictable latency. So you can't predict how long an event is going to take to go through your system, and you really need to factor that into your testing strategy. And the second one is also distributed systems. So you're going to have lots of different services, and you might consider deploying different ones in order to do an end-to-end test. But as we'll kind of describe as we go through this talk, that might not be the right thing to do. And so traditionally, you might have done an end-to-end test to see, do I get a 200 back from my service, which might include a whole big monolith. But realistically, with a distributed system, you will have to jump through quite a lot of hoops in order to perform that simple test. And then the next one is deciding what to test. As I've already kind of described, if you have a test for every single thing, it's going to be really time consuming, and that's going to really halt your delivery. So you need to kind of be quite picky about it. So moving on into what the traditional testing pyramid looks like. So we're all probably quite familiar with this. At the bottom, we have unit tests, and I'm not going to cover this too much because it's pretty much exactly the same as if it were a synchronous architecture, testing your business logic and mocking out third parties and just basically just testing business logic. So we'll kind of leave that as it is. And this should be totally comprehensive. Whether you're a startup or an enterprise, it's super easy. And especially with code tools now, there's no excuse really not to have your unit tests, and they run so quickly. Then we move on to integration testing, which is my favorite. I think this covers things really nicely, and we'll talk about this quite a lot. But we're going to work from the top down and put a question mark on end-to-end testing. And as I've already described, that can be quite challenging with distributed systems. So firstly, before we decide on whether we use an integration test or end-to-end test, we need to think about what we actually want to test and how we're going to test it. So firstly, we want to identify our business critical flows, and that's going to mean a lot of different things to different people, but we'll try to kind of narrow that down. So let's take a system where we have a cart service, and we have a front end, and the front end communicates with the cart service. And you can see that if an order's been placed, then synchronously, there'll be a network request to the cart service. And in the meantime, the front end's going to have some sort of a loading screen whilst it's long polling the cart service. So the cart service is providing an API, and all of these systems are decoupled. The cart service talks asynchronously to the marketing, payments, and reward systems, and they all don't know about each other. And this is kind of what we're going to work with for the next few slides. And then the payment system, when that talks to its third party and says, yeah, okay, it's going to send an asynchronous event back to the cart service, and then the long polling is going to succeed, and the payment goes through in a happy path. So business criticality is different for every team. But for the business as a whole, I think it's pretty clear that a payments outage would be pretty catastrophic because we can't just retry that. The user is sat there waiting for this to succeed. A rewards outage would not be great. It'd be a bad customer experience because the points wouldn't update on the points page, but we can handle that with error handling, and it's kind of a medium severity. And then a marketing outage, well, if the customer doesn't get an email, then it's not ideal, but it's quite an indirect profit loss. So as a business, that's how you can kind of frame it. But within the individual domains, if you're in the marketing team, you're probably going to want to define your business critical paths as a team, which would be that the main flow should work. But we're going to focus on payments and the critical flows as a whole system. So as you can see, I've kind of outlined where I think the main one should be because the customer is going to be directly affected. And the test, you may think, let's test that the cart service returns successfully, that we get a 200. But what is this actually testing if we wrote that test and just said, hit this API, what do we get back? It's testing that the cart service is working as expected. It's testing that the payment service is working as expected. And it's also testing the third-party Stripe. And this is obviously a very basic architecture, but just to kind of describe, you've got an API and then the event bridges are talking to each other. And then we've got our third party. And I kind of think this is quite problematic for many reasons. The first one being that there's a huge overhead in deploying both services in order to just perform this simple test. Nextly, we're coupling the services for the tests. Originally, we've decided to go with a distributed system for the benefits that we get from that. But now in the test, we're deploying both of them together. And so then there's a blurred responsibility between the teams, like who actually owns this test, who's going to maintain it. To me, it's not clear whether it should be the cart team or the payments team, given that both need to be deployed. Poor visibility of the problems. So if it is because payments is having an issue, the end-to-end test isn't really telling us anything. So the huge amount of overhead for that is problematic. And then we're also testing the third party, which we have no control of. And it's also going to be a huge amount of time in the CI pipeline. Mm. And so that's when I would probably say end-to-end tests might not be your best bet. On a side note, you may consider, if you're a bigger business, using something like Cypress or Playwright to kind of test it from the front end, but we're going to focus on the back end. So if we break it down a bit further and we look at the two systems, we can see I've added a bit more detail to the cart service, and we can see the payment service is using a step function. Yeah. And so what we need to look at is the cart service needs to think, what is the critical path for us? And that's going to be the API gateway, whatever needs to happen in the middle, that it puts the correct event onto the event bridge. And then we also have a critical path for the payments team where it receives an event and certain things should happen. And this is very much an example, but it could be that the correct event ends up in DynamoDB, that the step function is successful, or that, as you can see in this diagram, we're saying that a success event needs to be put back onto the event bridge so that the cart service can then be aware that it was successful. So to break this down for the cart service, the test that we want to perform is that if I send a valid event to the API gateway, then does a valid transformed event end up on the event bridge? And how would we test that? So the challenge that we have here is that you can't directly interrogate the event bridge for the correct event. So say, for example, we're using all AWS SDK in order to interrogate things such as DynamoDB in the next example, but event bridge, you can't do that. So the test would be, and you have to think about it kind of as almost an architecture in itself when you're designing these tests. So in the test, we'll make a post to the API gateway on a deployed stack. And then we're going to also, before that, have an SQS queue deployed that's just for the test with an event bridge rule so that we can then interrogate the SQS queue and receive the message from there. And in case anyone is particularly interested, there was a post that I wrote 3 years ago, but still seems relevant. And that's kind of how to do this. So I won't dig in too deep into this. But also shout out to Alios, who I can see Ben all the way at the back, helped out on this a few years ago. So do take a look. But the point here is that testing asynchronous architectures, you really do have to think quite deeply about adding extra services sometimes, and is it worth it? So let's have a look at the payment service, which in this example is a bit more complicated. So we have different test scenarios that we could decide on. So when I send a valid event to the event bridge, is the transformed event, does it end up in DynamoDB? Secondly, when I trigger the step function with a valid event, is the step function successful? And thirdly, when I send a valid event to the event bridge, do I then get a successful message back on the event bridge? And I'm certainly not saying that you should write all three, but they're just different things that you might consider. So this may seem fairly overwhelming. I probably should have put some animation. But for number one, what we're going to want to do is send a valid event onto the real event bridge. We'll have all this deployed before we've started. And we'll use the AWS SDK to interrogate DynamoDB. And then for number two, we're going to use the describe execution command from the step function AWS SDK. And for the third one, we're going to do exactly the same thing that we just did with the previous one and deploy the SQS queue to interrogate the event bridge. So to dig into that a bit further, for the first one, we're going to trigger the event bridge and then perform the get item on the Dynamo table and then assert that the item is correct. But the challenge here with the asynchronous architectures is how do we wait for the item to arrive in Dynamo? And the reality is that you do just have to put some kind of clever wait in there. And you want to make sure that your tests aren't flaky because that's going to cause you more time as well. And so no one needs to kind of read through all of this. But the point is when we do the get item from Dynamo, the nicest way that I've kind of found of doing this is by using a recursive function. So you can see that we're actually passing the get item it's a query command from Dynamo in order to keep trying until the item arrives in Dynamo. And so the retry function with backoff would look something like this. And essentially, I mean, you can see kind of we put in different console logs because it's quite a nice experience when you see it happening in your terminal. And the way this works is we've kind of said, well, 5 times seems to work every time, and we rarely ever get failures. So you need to kind of like iterate on these and make sure that they're not becoming flaky because it is difficult with the time that you have to wait sometimes. So then secondly, was the step function successful? So what you're going to want to do is trigger the step function directly using a valid event, and then perform the describe execution and assert that the step function was successful and any outputs that you want are there. And there's another challenge here, is that as you can see down here, when you have lots of different step functions happening, it's hard to actually go and interrogate the one that is the test. So how we've kind of combated this is by actually passing in a name when you trigger the step function, so you can generate a UID or something else, and then execute the state machine, and then you can get the execution using the ARN, and you can use that UID with some various things in order to get it. And so the next part is, again, you can see the way that we've done it here is just to, if the execution status is running, then you just need to wait and use a recursive function in order to get the succeeded version. And you kind of need to decide, is it worth it? And if it's on the critical path, then it probably is worth it. And so there is a reason why I chose to directly invoke the step function rather than putting the event onto the event bridge first, which seems to cut out and probably isn't ideal, that step. And it's because then you can't pass in the name. And so what you would have to do is kind of do a bit of an awkward fetching of lots of different step functions and interrogate each one until you get the correct one, which is definitely not ideal in my opinion. And so the third one is, if I put an event onto the event bridge, then do I get a success event back? And so, as you can imagine, it's triggering the event bridge recursively, performing a receive message on the SQS queue that we've deployed, and asserting that the event was correct. And so at the end of all of this, you need to make sure that you're cleaning all of these resources up, in particular the SQS queues, because you're going to end up with tons of resources if you don't do this every time your CI runs. And so a question that you may be asking is, should third-party services be mocked? Because as I described earlier, we don't really want to test that Stripe is working because we just can't control that. And the answer is kind of frustrating. It really does depend. And I will share my opinion after a few slides. And so what we can do in order to mock third-party services, we have the reality, which is Lambda calling Stripe. I would hope that Stripe is up most of the time. So a reason why you might mock, as well as not testing the code that you don't own, is it may block your developer workflow, because if Stripe is failing and your CI pipeline relies on that, then that affects your delivery. So you may want to consider setting up mock endpoints which return realistic responses. And you might have heard of an open source tool called WireMock to do this, and it runs on a Docker container. They also have a serverless offering, but it's based on Java, which is not my language of choice. So there's a lot of kind of complexity around setting this up. So it is powerful, but you need to decide if it's worth it for you. And so if we have a look at this table that I've built up, you want to only test code that you have control of. So mocking third parties is a great option, and no mocks isn't going to do this. Now, you also want to have low overhead and low cost, but if you're having these servers spun up, then it has to run on like EC2 or ECS. And if you're going to do one per mocked third party, then that could become quite costly, not just from the ECS costs, but also from time. And mocks also need to be kept up to date, which can be a bit of a pain, and could be kind of sidelined. And then you also, a key reason why you might want to mock is the ability to test failure scenarios, which, of course, I've gone through all those nice happy paths, but often the error handling and things like that are left neglected and can break without you knowing. So that's a huge reason to test, to mock unhappy responses from third parties. So if it's worth it to you, then that's a really big reason to do it. And then, of course, if you are having issues with your third parties, then you're going to have problems in your CI/CD if your third parties are going down in your test line, and so that's a good reason for mocking. So no one ever asks my opinion, but I'll give my opinion. So I think I would say unless you're a pretty big enterprise with maybe some dedicated people to work on this stuff, then I probably wouldn't do it. If you have a really unreliable third party and it's slowing you down, then maybe you should change third party. Quite familiar with that problem. And so I would kind of say maybe it's worth it if you have the time and resources to be investing in it. And also, especially when we're coming at this from a serverless perspective, and now you're asking people to deploy Docker containers, it can feel like a huge overhead on the developers. And so moving on from testing, this is a long old speech, but basically you can't actually catch everything without testing in production. And this was, again, Luke's quote from the book. And so we must observe in order to recover. And so you really do need to get observability right. You don't want to have too much of it. So you want at-a-glance dashboards, so just have the really important stuff on one dashboard. Regular alert refinements are key because you might find that you have too many alerts or not enough alerts, and it needs to continually be refined over time, maybe every 2 weeks or every month. And you only want critical alerts because all too many times do I see people ignoring alerts and noise. I mean, it happens to us all the time. So we have like a dumping ground Teams channel for just all errors. And then we have like a key one that we should really pay attention to. And then you also want to have It's called capability alerting. So you don't want 3 alerts going off at the same time for the same problem. You want to try and like combine those into one alert. And the whole reason is just so that you don't start ignoring things. And so if we want to zone in on a problem in production, firstly, we need to have awareness. That's key. So alerts are your best friend. And then we also want to have visibility. So as soon as we've got the alert, we want to head to the at-a-glance dashboard and check what the problem is. And then we need to have some understanding. So that's when traces and logs come into play. And then we'll have a diagnosis. And hopefully that's going to help us to recover really quickly. And so if we have a look at step 1, awareness, a classic scenario is CloudWatch logs that are streamed into an observability tool, and then a webhook to notify, say, Teams or Slack or whatever you choose. And a good example of how that might look, and one that we have, is like high 500s on API gateway. And a great thing about this is there's a link to go directly to the dashboard. And so for visibility, the quick link shows the problem. We can see the problem is over, so we don't need to panic too much in this scenario. And then we go to the service dashboard that it's affecting, and we see API gateway errors. On the same one, we see the Lambda error breakdown, and we can see that it did make it through to the Lambda. It wasn't just stopped at the API gateway. And then because I know that there's a third party involved in the Lambda, go check the third party response time, and we can see that that was a peak. And so I'm pretty sure that it was the third party that was a problem, but if we check the logs, then we can see that there was a timeout, likely due to the third party. And so at that point, you then go contact the third party and see if that was the issue. So just to summarize, we've had test and observe, and if anyone's interested, then come and chat to us about recovery and deliver. All 4 need to be balanced out really well in order to operate nicely. I appreciate we don't have a huge amount of time, but I'm going to ask Sheen. You wrote an article on what the role of a QA is in all of this, because we've kind of talked about this, but who is actually responsible? So do you want to give your thoughts on that, Sheen?
Yes. So this is like a debatable topic. So how many of you from a team where there is no dedicated QA engineer? Excellent. Thank you. There's so many. So I've been kind of observing how backend teams, especially in the event-driven serverless era, operate. And many times I see there is no impact to the engineering team when the dedicated QA engineer goes on holiday or they move to a different team and they find a long gap before they fill in the gap. And also then I looked at certain teams where on purpose they operate without a QA engineer. So that's kind of the basis for this article that I wrote, where I kind of debate few things, why, where it benefits or where it, like a status quo. Because in the past, we had a QA engineer or we have to have a QA engineer. But there are certain situations. So that's kind of the background why I wrote this article.
So do you feel that we need a QA engineer in the team?
Yeah, so it's always like it depends. So I say yes, or no, or depends, or maybe, or the right answer could be all of the above. I say this because it depends on your team setup and the domain you focus on. Say you are a full stack with the user experience element, then I think it makes sense to have a dedicated QA engineer, because you don't want your users get impacted. Similar to, when you operate in kind of a shared environment, whether it's the account or domain, I wouldn't recommend sharing a domain or bounded context between 2 teams. That brings all sorts of trouble. And then often in a regulated environment where you need to really scrutinize before you push anything out to your customers or production. So these are the situations where it may benefit. But in a typical kind of, microservice building common situations, you can experiment without QA engineer. So that poses the question then, whose responsibility is quality?
It's everyone's responsibility.
Yes, indeed. It is everyone's responsibility. Quality is everyone's responsibility. Similar to how we are pushing the security all the way to the left. Quality also going that way because it starts when you start off concepting your ideas. Because QA should be part of how when you design, when you discuss, when you review. It's always there. It's not just like when you raise your PR to act as a PR gate or something. It's always there. And for that matter, it's not just EDA. Quality is everyone's responsibility everywhere.
Thank you, everyone, for joining, and thanks to EDAD for having us. So there is Sheen's book signing directly after this downstairs. I believe that there's 33 copies and maybe about 20 at 40% off. So worth going down and getting your hands on a copy. It's a good read. But yeah, thank you.
Thank you.